So this is an overview of the synchronous machine setup for use in a synchronous machine inverter-based generating lab that will allow us to parallel multiple sources as well as monitor loads and generate power, specifically 120 volt / 24 volt AC power for use in the lab. What you're seeing right now is the front panel display for the device. Now, this is going to be the main point at which the students will interact with the equipment. It is completely safe to touch with banana plugs for being able to take measurements of all sorts. On the right, you'll see the only LED that's currently lit right now is the variable speed controller. That is powered by a single 120 volt AC plug-in source. So there is no need for the students to interact with any other specific requirements or any other hazardous voltages as part of the work that they're doing. So let's bring the machine on and see how it works. Starting by turning it on there, we're going to see that we're already spinning at a pretty decent rate, and we're generating a little bit above our design voltage. So we have a generator frequency and voltage indicator light on there, but currently we have no load going on. Now, this is going to give us our system voltage and frequency when we are paralleling our sources. This is going to be our synchronism check element to ensure that we can indeed synchronize those sources. And these are going to be our loads, some low wattage light loads, as well as some high wattage AC fan rotary loads. Now, I will say that the synchronous machine at the heart of this is just a 10-watt synchronous motor. So unfortunately for the fans that I have, they're not really capable of keeping up. Now, in the course of the lab, when we want to actually bring our sources online and synchronize them together, we have our source 1, which is our local source. You'll see every time we add load, we're going to put additional burden on that machine. So this will be an opportunity for the students to see what it means to put burden on a machine and how you're going to compensate for that via the labs. Now, I don't have the inverter-based source right here, but normally that would be turned on this side, and we'd see our source and relative frequency to each other. Here we have our three low wattage loads, and you'll see that we actually have a very minor influence on the condition of the machine, but we can bring our machine rotation down, see our voltage drop, and see our lights start to dim. Likewise, we can control that voltage up and down, and you'll see as we start to come into our synchronous frequencies, we'll see our frequency meter start to give us some values that we have there. Again, the main source of our synchronism check is going to be our elements that we have right here. That is the synchro phasor meter that we're looking at right there, which will help us understand what the different values are at any time while the students are interacting with them. Now, I do want to show you one particularly interesting portion of this is that the fans that I have, that is the rotary loads, the inductive loads, are substantial compared to what we are dealing with here. So because of that, when I bring on that fan load, it's going to bring up my system voltage pretty far down until that fan comes up to speed. So it's going to require the students to be able to, and it's part of the problem with being able to do that, that load is relatively substantial, and so that means the equipment struggles to keep up with it unless there's another source in parallel. Now, this equipment is designed such that multiple sources can be parallel together, so that means we can add additional generators, we can add inverter-based generation, we can add a lot to this, and they can be paralleled right here via the source to in. We also have the ability to export 24 volts AC from our generator source to either an external load, either through these or through another machine like this, that will allow us to synchronize multiple sources together. Now locally, we can synchronize two sources together when they are synchronized via our synchronism check relay by closing the contactor right here. Now, I'll show you what that looks like on the back side of this in just a moment. Alright, so here we have the back side of the machine. As you can see here, we have our primary driver right here. This is going to be a 120 volt AC induction-based motor. I'm only using this because it's a gear-reduced motor, high-torque motor that allows us to drive a variable load of almost any potential variation that we want to via the integrated controller that I've put in here. We can see that is driving a relatively small AC synchronous motor, which is able to output our base frequency when run at a very specific, when run at our mains frequency revolution, or rather the revolution of the machine. These are geared motors, so the RPM of the synchronous motor in this case is 30 RPM. You can see a strip slowly going by on that. That allows the students to apply a tachometer so that they can verify the speed of that machine while they're also dialing it in on the front of the device. Now, here we have our two transformers. I'll be completely transparent. They are doorbell transformers, so converting 120 volts AC, which is the output of our synchronous motor, into 24 volts AC for use in the lab. From there we go to a number of different blocks. We have our AC contactor right there, as well as an AC rectifier for our 24 volt DC supplies that we're using in here. Now, we have the opportunity to potentially encapsulate the entirety of this for the safety of the students, but realistically almost everything here is finger safe, so there are very few things that they would be able to otherwise interact with that would pose a hazard to them. But from the back side, there's a lot of opportunities for them to see several of the different power components that they need to be familiar with. For example, the use of induction and synchronous machines, the use of transformation, as well as the integration of AC and DC controls on this equipment. So all that together means that the students have a lot of potential lab work that they can do with a rig setup like this, and a lot of different experiments that could be built from something like this while also integrating other components, for example, the inverter-based generation lab that you already have.